go. Okay, average rate of change. This is going to go back to, do y'all remember learning slope in like 7th grade math? Yep. That's basically all this is. That's all this is. The average rate of change of a function over some sort of interval is given by this expression. This is technically based on, derived from the formula for slope. So you can actually see that in here. So you can see it's change in y over change in x, which when you first learned how to do slope in like the 7th grade, you learned it was y2 minus y1 over x2 minus x1. And then all we do different to make this average rate of change that we do for a polynomial function is that it's written in function notation. That's the only thing that's different now. It's written in function notation. F of b minus f of a, which still means y minus y, over b minus a, which still means x minus x. It's a measure of how much the function changed per unit on average over that interval. And again, it is derived from the slope of a straight line connecting the interval's endpoints on the function's graph. So the first couple, we're going to learn how to do average rate of change from a graph. Then we're going to do some from a table, and then some from an actual function, just given some inputs. Okay, what is the average rate of change of the function f over the interval when x is between 0 and 9? So first thing I'm going to do is I'm going to identify the 2 points on the graph that relate to this interval. So the start of this interval would be when x is 0. So I'm going to go down and I'm going to find that point on my graph. That would be this one right here when x is 0. What ordered pair is that? 0 what? 0, negative 7. Good. And then I'm going to go look for when x is 9. That's the end of the interval. That's the one over here. And what ordered pair is that? 9, 3. Very good. So we need to find the average rate of change between these two. So I'm going to take those two and I'm just going to write them down just like how you normally would for slope. 9, 3. And then again, the only thing we do different for average rate of change than what you learned initially for slope is that this is usually written in function notation. So instead of saying x and y, we would just say this is a and this is f of a. This is b, this is f of b. Otherwise, it's mathematically the same as when you first learned how to do slope. We're going to substitute that into our average rate of change formula. Okay. On the top, I'm going to have my f of b minus my f of a. That would be 3 minus negative 7. On the bottom, we'll have our b minus a, which would be 9 minus 0. We'll simplify each of those places. 3 minus negative 7 would be 10. 9 minus 0 is 9. If the fraction does reduce, you can reduce it. Does this one reduce though? No. So that's it. That is our final answer. Like I said, easiest since you've done since 7th grade, right? Memories. All right, looking at the second one. The second one's a polynomial function just facing a different direction, but still a polynomial function. This one's name is function g, and we want to find the average rate of change over the interval from when x is negative 8 to when x is negative 2. So again, first thing I would do is I would just identify those 2 points. When x is negative 8, that is this point down here. Negative 8, negative 8. And then my second point when x is negative 2, this is right here, which is negative 2, 3. Okay, we'll use those 2 points to find the rate of change between. Does it matter which one you write down first and which one you write down second? No. Same thing whenever you initially found slope in 7th grade. You'll get the same answer no matter what order you write the 2 points in. I'll get those labeled. This is my a, this is my f of a, this is b, f of b. We'll substitute those into our average rate of change formula. On the top, we'll have what minus what?
Yeah, because that's right.
What minus what on the top? 3 minus negative 8, yeah. And on the bottom, we'll have negative 2 minus negative 8 again. 3 minus 8 would become 11. Negative 2 minus 8 would be negative. Oh. Negative 2 minus negative 8. There it is. Negative 2 minus negative 8 would be a positive, 6, right? Does that reduce? No, it does not reduce. Pretty simple.
Are the
So,
symbols always going to face that way? Does it matter?
what do you mean face that way?
Like the greater than or equal to?
Yeah, it's kind of like how they would write the domain. They're just asking like, what is the average rate of change over this domain? All right, look at it from a table on the back side. Find the average rate of change over the interval from when x is 11 to when x is 15. So when you're given a table for this, you only want to pay attention to these two x values for points. So looking in my table, I want to see, well, here's the point when x is 11. Here's the point when x is 15. Are the other two important? No, we will not use those in our calculations. So we're going to write down the 2 points that we're finding the average rate of change between, 1179 and 1589. Okay, we've already got them labeled, so we'll go ahead and get those substituted into our average rate of change formula, and then we'll simplify. On the top, we'll have what minus what? 89 minus 79. On the bottom, we'll have 15 minus 11. So that's 10 over 4. And what does 10 over 4 reduce to? 5 over 2. Or if you wanted to write it as a decimal, 2.5. Either way is perfect. Getting the hang of it? All right. For the next four, all four of the next ones are going to use the same table. This table that talks about the different years and price of gas in dollars per gallon. It shows it from 2010 to 2015. The first one we're asked to do is find the average rate of change in the price of gas from 2010 to 2014, which means we only want to use those 2 points to calculate the rate of change. So I'm going to start with 2010 was $2.84, and then 2014 was $3.42, and then we'll use just those 2 points to calculate our average rate of change. On the top, we'll have 342 minus 284. And on the bottom, we'll have 2014 minus 2010. There are calculators on your desk if you need it for this question. 342 minus 284. 0.58.
Yeah.
Over 4. So 58 cents divided by 4 would be 0.145. What is this in money? Yeah, technically that would be how many cents?
15.
Almost 15, yeah, 14.5 cents. Did y'all ever notice that gas prices actually give you the thousands place? You'll notice it now. Gas prices, like, if you go to a gas station, it'll say this number, and then on the side it'll say 9 over 10. Like, they always show the thousands for gas prices. I don't know why. So this is technically 14.5 cents. 14.5 cents. Okay. That's positive. Do you think that represents an increase or a decrease? That's an increase in price, right? We're going to repeat that same process using the table, but now we're looking at 2010 to 2015. Okay, so first year is the same, second year is different. So 2010 was still $2.84, but on this one, 2015 was $2.51. Okay, again, we're using these 2 points to find our average rate of change. On the top, we'll have what minus what? 251 minus 284. 0.
Oh, wait.
And on the bottom, we'll have 2015 minus 2010. Again, if you need a calculator for this one, I did leave some out floating around. 251 minus $2.84 would be negative 0.33. over 5 years, and negative 0.33 divided by 5 years would be negative 0.066. What is this in money?
6 cents.
6.6 cents. Yeah, almost 7 cents. Or technically negative 6.6 cents. All right, based on those two, we're gonna fill in the blanks on the little sentence stem on number 3. It says, what do these two average rate of change tell you about gas prices in the United States between 2010 and 2015? Between 2010 and 2014, there was a how much cent change? 14.5 cent. Was it an increase or a decrease? Increase, yeah, because it was positive. Okay, and then between 2010 and 2015, there was a decrease of 6.6 cents. This is that negative. So depending on what 2 years we use on the interval. So the first one we use 2010 to 2014. Second one we use 2010 to 2015. You get different answers depending on what intervals you use. Depending on the intervals you use, you get different answers. Based on this, you can conclude that between 2014 and 2015, you can even actually see it. There was a pretty significant decrease between these two. To change the overall average rate of change from being a positive to being a negative, that means there's a pretty big decrease between these 2 years. So between 2014 and 2015, there was a significant decrease in price of gas per gallon. All right, part 4. Assume that the average rate of change from 2011 to 2012 continues through 2025. What would you predict the price of gas to be in 2025? What do we need to do first? Find the average rate of change between these two, right? Find the rate of change just between 2011 and 2012. So I'm going to write down those 2 points. 2011 was $3.58. 2012 was $3.69. Let's see, doing that rate of change. $3.69 minus $3.58, 11 cents per year. Is it increasing or decreasing? It is an increase because we got a positive, right? So we're trying to figure out what would it be in 2025. So let's think for a second. If we went from 2012 to 2025, how many years would that be? That would be 13 years of change, right? So then what we need to think about is that it would change 11 cents per year for 13 years. So we would do 11 cents times 13 years. 11 cents times 13 years would be how much money? $1.43. Good job, guys. So that's going to be the monetary change between 2012 and 2015. Or sorry, 2025, excuse me. So then what we'll need to do, I heard Fulbright say it already. What's the last part, Fulbright? Added to the 2012 year, right? So you take 2012's amount, which was $3.69, and you add the amount that it changed over that time, which was $1.43. And that should tell you the predicted gas price in 2025. Which is how much? $5.12. And you say, good Lord, let's hope not. These are California prices. No, thank you. We make the gas here. Should be cheaper to have gas here. Expected in 2025. There's a similar one like this on your homework that's going to anger you. It's going to give, it's about minimum wage and what the minimum wage should have been in this year if it followed the same trends as previous years. And it's just going to piss you off because our minimum wage is nowhere near what it should have been predicted to be. Yeah, that's minimum wage, yeah. It's like some sad 7 number. Dude, when I was in high school, it was like $6. So that was 20 years ago. So, anyways, it'll just anger you when you do the homework. Okay, last rate of change that we're going to look at is how to do it when you're given just the function itself and some sort of interval. Also, instead of using inequalities for this interval, it's given in official interval notation. So remember, when something's in interval notation, these are both the x values of the interval. So this is telling you like when x is -2 and when x is 5. Both of those are x values. So in order to find the rate of change, I still need to find the y values for both of these. So we will just plug it in. So we got to plug in -2 and we got to plug in 5 because we need to find what their y values were. So plugging in -2, -2 squared plus 3 times -2 minus 4. Let me see, that would be 4 minus 4 minus 6, so that's -6. So what ordered pair would that be? We plugged in -2, we got -6, so that's the ordered pair. No, that's the ordered pair -2, -6. You're getting ahead. And then we're going to do the same when x is 5. We need to find the y value when x is 5. So that's 5 squared plus 3 times 5 minus 4. That's 25 plus 15 minus 4, which would be, what is that, 36? Okay, and then how would I write that as an ordered pair? 5, comma,
36.
Very good. And then once I have the 2 points, now it's basically like the ones we did with the table. We're going to use just those 2 points to help us find the average rate of change. Okay, so on the top, we'll do the output minus the output. So that's 36 minus -6. And on the bottom, we'll have 5 minus the -2. We'll get that simplified. What was that? 42 over 7, which simplifies to 6. Okay. For the last one, we're given the function as -3x squared minus x plus 2. Okay, and we want to find the average rate of change over the interval from 0 to 3. So again, first thing we got to do is we got to actually find what points 0 and 3 are between. We need the actual y for both of those. So we have when the x is 0, we have when the x is 3, but we got to find the resulting y values. So in the first one, I'm going to start by plugging in 0 to the function. So that's -3 times 0 squared minus 0 plus 2. What is that going to simplify to? 2, yeah, equals 2. So what would be that ordered pair?
0, 2.
0, 2. Okay, for the second one, we're plugging in 3 for both of those x's. So we'll have -3 times 3 squared minus 3 plus 2. Do I multiply first or do I exponent first? Exponent first, right? So 3 squared is 9. 9 times -3 would be -27 minus 3 plus 2, which is -28, right? -30 plus 2. And then putting those together as a point, that would be 3 -28. And then once we have those two, the last thing we got to actually do is find the rate of change between those 2 points now. Oh, did we lose you? Alyssa, you good? It looked like we lost you for a second, yeah. All right, for my average rate of change, we'll do the change in the y's, which would be -28 minus 2. On the bottom, we'll do the change in the x's, which would be 3 minus 0. So it would be negative 30 over 3, which is an average rate of change of negative 10.